Hello, I'd like to invite you to find out more about water recirculation systems, better known as RAS.
We start our tour in the fish tank storage area. Let's take a closer look at the different components in each tank. This pipe allows water to be fed into the tank, adjusting the rotation velocity. Inside the tank, a hydrostatic sensor regulates normal operational water levels. In addition, an emergency sensor alerts the operator to water level anomalies. Each tank is equipped with an oxygen sensor, which controls the amount of oxygen injected into the water to ensure the required levels, and acts as a support for basal oxygenation and as an emergency system in case of power failure. Inside the tank, electrical spreaders automatically distribute the feed and pulses over the whole surface of the water. In addition, the hoppers are automatically refilled using a distribution system, which eliminates the need for manual feeding. This is the dead fish removal box, which is connected to a pipe running from the central outlet. The fish are transferred via an air lift system and extracted during the daily tank cleaning routines. Live fish are returned to the tank through a perforated grid. The water is routed to the Ras water treatment unit through a bottom central drain pipe. We continue our tour in the water treatment area, also called the RAS zone. Let's take a closer look at its different components. Water from the fish tanks flows into a chamber upstream of the mechanical filters, where each pipe is fitted with an emergency valve. These valves, controlled by a pneumatic piston, close automatically in case of power failure to prevent water loss. Once in the pre-chamber, the water flows into the RAS through mechanical filters, which are rotating 40 to 90 micrometer screens that retain the suspended solids in the water. These filters have an automatic washing system that operates according to the water level. The resulting sludge is sent to a treatment plant, while the filtered water accumulates in Reservoir 1. Critical processes for the functioning of the RAS take place inside Reservoir 1, such as the make-up water exchange. Additionally, the pH is controlled to compensate for the decrease caused by nitrification, regulated by a pH sensor in Reservoir 2. From Reservoir 1, water is directed to the biofilters, passing through control valves that keep the reservoir level constant, ensuring an even hydraulic charge to the biofilters. These valves are automatically regulated by pneumatic actuators. From Reservoir 1, water is sent to the fixed-bed upflow biofilters, which consist of chambers filled with a plastic biomedia bed. The nitrification process, which is the oxidation of ammonium to nitrate, takes place within the biofilters. Since these are fixed-bed biofilters, they require a backwashing process, which is carried out automatically with air agitation and subsequent sludge discharge using a self-priming pump. After passing through the biofilter, the water is directed through perforated pipes to a degasser, which in this case is a vacuum trickling degasser. Filter elements called bioblocks help to disperse the water flow to increase the gaseous exchange between the water and the air. The air leaving the degasser contains high concentrations of carbon dioxide and nitrogen gas. Once completed the degassing process, the water accumulates in Reservoir 2, located below the bioblocks. In Reservoir 2, a series of control processes are carried out. In this reservoir, the water coming from the temperature control system is adjusted to return to Reservoir 2 at the desired temperature. In addition, a salinity sensor measures the salt concentration. Depending on the selected setting, the sensor regulates the seawater intake valve. Reservoir 2 is also equipped with an emergency overflow system. From Reservoir 2, water is pumped through circulation pumps to the header tank. An ultraviolet filter is attached to one of the pumps to disinfect some of the water and control the microbiological load. Then, the water accumulates in the header tank and is distributed to each tank to restart the circuit, first passing through the oxygenators. Oxygenators are located downstream from the header tank, before the fish tanks. These passive low-head systems take advantage of the pressure provided by the water column inside the header tank to increase the oxygen injection efficiency. Their main function is to dissolve oxygen in the water to maintain the required concentration within the tank.
I hope you have enjoyed this tour, and we invite you to help us continue building the aquaculture of the future that is more efficient and sustainable and committed to contributing to a better world. Thank you.